So I'm Roberto and work for Spendesk, a fintech company. Specifically, I work for the public API project. And today I want to talk about a very, let's say, a real life experience that I had while working, especially on large code bases. It happens, especially in my previous company, about some painful things that can happen and how you can leverage some very nice open source tools to at least simplify your life as a developer. So let's start talking about what I call the pyramid of pain, and let's imagine ourselves as people that want to climb this pyramid of pain. And this, again, happens a lot. Of course, if you work as a solo entrepreneur for your simple GitHub project, maybe you don't have this kind of issue. But when you start to work on a very large code basis, this happens a lot, especially all of the parts regarding tests. So usually what happens is that tests start to become very slow, they're flaky, they're unreliable, and so basically people start to not being able to merge to master, you cannot release things, you cannot release bug fixing, so it's a very nightmare situation. But yeah, let's try to think about every different step and how can we climb every different step and finally reach what should be our goal, our dream, a very great developer experience where we have a very nice code quality, we have a code that is safe, it's well tested, it doesn't take ages to run in our CI, so something that I think all of us as developers want. Let's start about the first pillar, so performances. Again, in this case, we are talking about performances regarding specifically the CI and in particular the tests. So what I did so far, and imagine in this case, Steve Ballmer saying benchmarks, basically was to analyze the differences between a very famous test framework that probably many of you know, which is called Jest, and I used it. I'm using it in my current company. I used it before. It's used everywhere, basically. And then I said, okay, why not analyze the differences between the Jest framework and the new Node test runner and see what happens, no? So what I did was very simple, create a basic test that does the exact same thing with the two different frameworks, create a script to copy the same test again and again to simulate what happens when you have a very large code base, so you have tons of tests to run. And finally, analyze the benchmarks, something very simple. So this is actually the code that I created. In the first slide, in the first image, you can see the Jest code. In the second one, the Node code, apart from importing some syntax, some functions to detect if the result of the test is correct, basically the work is the same. As you can see, we are just testing that a sum function returns the proper value. Very simple. The goal is not to create some rocket science test, it's just to analyze the benchmarks running it. Those are the results. So basically on the left column, you can see the Jest results, and on the right one, the new Node test runner. As you can see, the higher the number of the tests, the better the results. Specifically for the last one, we are talking about 10,000 tests, which is a situation that in a large company can happen, and you can also go above this line. And we are talking about 900 seconds to run those tests with Jest and 80 seconds with Node, which is, I think, something crazy. But I know I also was like, in this meme, I was thinking, okay, maybe this is just, it's just a very dumb test. I mean, when we start to create something that regards, I don't know, integration test, mocking an API, running a database, all of this kind of stuff that you usually do in a test, what happens? And so I basically migrated a small repository, but with some tests that were, I would say complete. So we're talking about unit test, integration test, database checks, this kind of stuff. And again, the results are quite promising because, again, we're talking about around a 5x improvement by using Node. So basically, I would say that the performances by using the new Node Test Runner are very, very interesting. But now let's talk about another point, which is globals override. Again, this is something that happened to me while creating tests using Jest. And I ended up like in this meme with this phase specifically. So I created the code that you can see in this part, so in the part below. And basically here we're using the very nice library from Matteo Undici to mock an HTTP call. And then the test was not working properly. So by calling the fetch method from Node, basically nothing was mocked. And I would say, what the hell, why is it happening? And then I said, okay, let's try to create the exact same test, but using Node. And the last one is, it's working. And so now you may wonder, why this is happening? And the response, you can find it on these GitHub issues, and there are many others, is that Jest overrides some Node.js globals. So you cannot trust what happens, and if you have a very complex test to set up, and this happens, good luck to debug it, because it's very hard. So yeah, again, a recommendation to use Node test is also because your globals will not be overridden by it. Now let's talk about another very, very important topic, dependencies. I think all of you have already seen this meme. So yeah, basically, we all like open source, we all use open source, but yeah, if we can avoid to add a lot of dependencies, and again, when we talk about Jest, we are not only talking about the framework, we are talking also about importing the types and maybe other libraries that interact with Jest. So yeah, by using Node.js, you already have it in your core. So you don't need to install any other new dependencies. You don't need to maintain it. You don't need to think about security for it. And so basically it's inside Node. So if you use Node, you can just use the test runner and avoid to make your code base and your Node modules folder more big. And before to start the next point, I'd like to talk a bit about Fastify, especially some of the key points, at least what I found so far by using it, regarding developer experience while using Fastify. The first one is that you have built-in validation. This means that everything that happens in your endpoint, so the parameters you receive, the data you expose, everything is validated. This is the first very nice point. The second one is that the performances are high. Again, I created some benchmarks. I'm not showing in this event because I don't have time, but yeah, by comparing it with other frameworks, performances are very, very nice. And finally, the developer experience is good. Also, the integration with TypeScript, if you use it, it's working quite well. And yeah, so we tried Fastify to solve another problem, again, regarding tests, which is starting HTTP server. Because, yeah, when you have to handle active servers in your test that maybe are running concurrently, well, it's not easy. You can do that, of course, but if you can avoid to run a lot of servers in your tests, it will simplify a lot the development. So a very nice feature about Fastify, apart from what we mentioned before, is that it also uses a module that is called the Light My Request. So Fastify provides these methods, which is called inject, thanks to which you can basically test the code inside your app, the plugins, everything that runs, but without actively running a server, which simplifies a lot. Yeah, creating new tests and handle them in concurrency. And this is how it looks like. So basically, before to run the test, you instantiate your app with the settings that you need. Then you just call inject. So as you can see, we are not listening for the app. We are not, we don't need any new port available, this kind of stuff. We just use inject by calling the Fastify instance. We pass the URL, in this case, of the health check, and then we can detect what is the response. Again, very easy, and it simplifies a lot your tests. It's also very much faster to run, because you don't need to wait for your tester, for your server to be listening for new requests. And now, another pain. So I think most of you ended up in this situation where you have a server, a client, you have maybe a wonderful documentation, stuff like that, but then someone updated the server, forgot to update the documentation, forgot to say, hey, I updated this endpoint, and then basically the client is completely wrecked. So how can you avoid this situation? Again, by leveraging some very nice open source tools. Again, the first idea is to use Fastify, by which you can validate your schemas, and then leveraging another plugin, which is the Swagger plugin, you can have an open API definition for all of your endpoints for free. So basically, you will have a JSON definition of all of your endpoints. And thanks to this, you can now leverage another tool, which is the Platformatic client, that gets this JSON definition and generate what is called a fully typed client. So you can also have TypeScript types. You will have a plugin thanks to which you can also generate headers for your request. So imagine you need to send an authorization header for every request. You can do that with Platformatic client. And then you can securely call the API. And we are using that in production. It works damn well. And also, if there is a breaking change, we can run a command, download the latest OpenAPI definition, and see if the code breaks, for example. And again, this is how it looks like. Of course, I had to cut a lot of other code, but those are the main pillars, let's say. So after you have used the Platformatic client CLI, which is the module that basically generates the schema definition and the types for you. Now you can register this plugin, this Fastify plugin. You pass a few parameters, and if you use TypeScript also, you will have, let's say, type safety, so it will tell you what you need to pass. Basically, you need to define this name that is used later on, because it is attached to the request. So this is a Fastify decorator that adds it to you. You pass the URL of your API, the path where you have your OpenAPI definition. If you need some headers in addition to send, you can also create an asynchronous function that adds headers to every request. And finally, what is the final result? That once you instantiate those stuff as a plugin, so in just one place, that's it, every request that you do will have a very simple syntax. And basically, every new parameters that will be needed will be automatically detected by this code. So the end result is the last line of code. You just called request, which is the Fastify request object, .client, which is the name that we set it up initially. And then you will have also a lot of nice features. As, for example, if you use VS Code, you will have the list of literal names for your endpoints. And additionally, if an endpoint requires parameters, like query parameters, body, stuff like that, they will be asked to you. So I think this is a very nice way, especially if you have to handle a lot of different endpoints and the changes between them, to have something that works well at scale. And yeah, let's talk about the final pain. So as we mentioned initially in our journey, we talked about the fact to have large code bases where the CI/CD is very slow, it's unreliable, you have a lot of tests failing, they are maybe not running well. But yeah, basically, to recap, if we do all of the previous steps, also the CI/CD steps will be way better, because to recap, by using the Node Test Runner, we have no external dependencies to add. There will be the no globals override issue. as we mentioned, and our tests will run faster. So those three main pillars are very important for us. But then by leveraging both the Fastify and Platformatic features, we can have no active servers to run on our tests. Our documentation will be automatically up to date. I've not shown it, but you can have a Swagger UI interface completely created by those two plugins. You can validate your input and have up-to-date clients, which is very, very nice to have, especially if you have a lot of teams interacting. So finally, your CI/CD will be more reliable, will be faster, and if you have a regression or a breaking change, it will be a lot easier to detect it, and you can detect it from code. So now you may ask yourself, okay, but I have an existing code base, maybe a very complex one. Where do I start? And my recommendation would be, as I said, to start small. So like in my case, I started with some very simple proof of concepts, just also to demonstrate also to other teammates what are the results, for example, in terms of performances. Then I gather a lot of benchmarks, a lot of results from those POCs, and I started to share it and talk about that with other people. And then my recommendation is take a pragmatic, a logical decision, not a sentimental one. I would say not choose a framework because you like it, choose a framework because it simplifies your life as a developer and because, I don't know, your tests run faster. So finally, then you can repeat those steps. So if you started with a very small repo, you can just repeat and take a more complex challenge with a more huge repo and start it again. And yeah, final note, just try those very nice open source tools. Again, those are open source. You can look at the code. You can contribute like myself. And I really like also to contribute to those projects because you can contact other people. You can learn a lot from others. So it's a very nice coding adventure, I would say. And the good part is that you will have less headaches having to debug very complex issues on your pipeline. That's it for me. Feel free if you have many more questions about that, or if you want to chat with me, let's have a beer, whatever. And also those are my social profiles. So feel free to connect with me. Especially I'm more active in LinkedIn than the others, but yeah. Thank you to the organizer for this nice event.